Hi, Assalamualaikum. Alright, so this is the first method under roots of nonlinear equation, which is bisection method. You have to remember our aim, why we use this method, is because we want to find the solution of x so that when you substitute into the nonlinear equation of x, you will get equal to 0. Okay, in other words, the question also can say find the root of the solution fx. Alright, let's look at example 1. Find the solution of exponential negative x minus x equal to 0 in the interval 0, 1 by using bisection method. Use 3 decimal places in all calculation. So you can see here you are given an interval 0, 1 where this is actually the initial value that you have to use in implementing the solution. Initial value. Okay, the initial value usually given in terms of interval. So in order to obtain the solution, usually I will suggest students to use a table. Okay, come up with a table so that your solution will be easier. What you have to write in the first column is the I. I stand for iteration, which is the number of work that you have to done. You have to implement in order to reach the solution. The second column is AI, which is the value of interval. The value interval or the value that you will use in order to get the the solution. And then the second column is BI. The third column is CI, where CI is the midpoint between the AI and BI. So AI plus BI divided by 2, you will get the CI. And then the fourth column is the FAI. Where you substitute the AI into FX, you will get the FAI. And similarly, FBI and also FCI. Alright. So now, we start the iteration with 0. You always has to start the iteration with 0. Like you do the graph, always start with the 0, right? Okay, so what is AI? Which is the interval given in the question, which is 0. And BI is 1. So means that here is A0 is 0, B0 is 1. And then what is C0? C0 is use 0 plus 1 divided by 2. So we get 0 0.5. 0 plus 1 divided by 2, we get 0 0.5. And then what is FA? You substitute 0 into the FX. Okay, you substitute 0 into the FX, you get 0 0.1. Okay, you substitute 0 into the fx. This is the fx. You will get 0 0.1. And then fb, you substitute 1 into the exponential negative x minus x. You will get negative 0 0.632. Look at here. I use 3 decimal places because it's written in the question that you have to use 3 decimal places. And then you substitute 0 0.5, which is the cu0, into the fx. You will get 0 0.1. 07. Okay, now you have to still continue the iteration to iteration number 1 because the FC is not equal to 0. Okay, so here means that you have to stop your solution when the FC is equal to 0. Stop when FC is equal to 0, or maybe FC is approach to 0, close to 0. Okay, or maybe it's depend on the stopping criteria. I will explain it after this in the example number 2 about that. Alright, so you have to stop your calculation when you reach the FC equal to 0 or the FC is close to 0. But now for this case, your FC is still not equal to 0, right? Which is 0.107. So you have to continue your iteration to be iteration number 1. So what will be your new interval, your new value of A1 and B1? Okay, now we are going to apply the intermediate value theorem. Intermediate value theorem say FA and FB, when FA and FB has different sign, or then there exists a solution between it. Also now, what you have to do when you're going to apply that condition, in this case, where you compare FA and FC, okay? Compare FA, FC or FB, FC. Okay, now FA and FC. FA is positive, FC is also positive. Is it have different sign? No. So that's not satisfy the condition. But FB is negative, FC is positive. It has different sign. Therefore, what happen will be the FA will take the value of C. This value, you can see this value now is goes to A. Okay, and then B is remain as previous. Okay, I repeat, you check FA and FC or FB and FC where it has to be, they have to have the different sign. Okay, now FA and FC have similar sign, so not satisfy the condition of intermediate value theorem. So you have to check FB and FC. Yes, both of them have different sign, one negative, one positive. So what happened? B take the previous B, which is remain, the value of B is remain, but A have to take has to take the value of C to take over to replace the previous value. Previously you have 0, but now it's 0.5 because it's take the value of C in the previous iteration. Okay, let us continue. So now we calculate the value of the new C, which is 0.75. 0.5 plus 1 divided by 0, 0.75. Then FA, now because you know that A is actually from the previous C, so why don't you just take from here, from the C that you obtained from the 0.107. You don't have to use your calculator because it does based on the previous value of FC, because A is take the value of previous C. So FB is remain because you use the similar B, and C, of course, you have to find the new C. So substitute 0.75 into Fx, you will get 0.278. It's still, the FC is still not equal to 0 or not close to 0, so you have to continue. Now check, FA is positive. Okay, FA is positive, FA is positive, and FC is negative. Yes, now A and C satisfied the condition of intermediate value theorem. So what happened in the next iteration, which is 2, FA is remain, okay, because FA and FC. So B, you cannot use the previous B, so you have to take the value of C to replace the value of B, which is 0.75 now. Okay, I hope this is clear for you. So now calculate the new C. So 0.5 plus 0.75, you get 0.625, and then substitute. This one is same 0.107 because we use the same A. B, of course, different. So B is take the value of C. So I take from here. I just take the value of C here, so just replace at the value of FB, so negative 0.27, and then find FC, which is 0.625, substitute into Fx, you get negative 0.090. Okay, then still not equal to 0, so you have to continue. So here check the condition. FA and FC have different sign, so what happened in the next iteration? You can see in the next iteration number 3, A is remain, but B is take the value of C. Then you continue your calculation. You can see here I stopped the calculation at iteration 7 because FC now is equal to 0. 0.000. So you can stop your calculation now. And what is the answer that you want is actually this one. This is the solution. This is the answer. So the answer, which is the x that you want, is actually 0.567, because when you substitute into fx, you will get equal to 0. So fx now equal to 0. Okay, clear, right? Okay, now, alright, move to example number 2. In the example number 2, you are given the value of epsilon. You can see here, find the root of x power of 4 minus x minus 10, accurate to epsilon 0.015. Okay, so this is called as the stopping value. Okay, you have to stop your iteration when you reach the value of epsilon 0.015. Alright, so first of all, as usual, you come up with a table consists of column I, AI, BI, CI, FAI, FBI, FCI, and also I add one more column where it will have the value of epsilon. So how to get the epsilon? It has to be based on the AI minus CI or BI minus CI. You can use either one. Okay, AI minus CI will have the same value of BI minus CI because CI is the midpoint between AI and BI. Alright, so epsilon here, you have to make sure the value has to be 0.015. Then you can stop the iteration. Alright, let's start with iteration 0. Expression 0, A0 is 1.5 and B0 is 2 based on the interval given in the question. You find the CI, C0, okay, the midpoint, and then you find FA, FB, and FC, and then you calculate the epsilon. So this epsilon 0.25 I obtained based on 1.75, which is C minus with the 1.5, or 1.5 minus 175, also same because we have absolute value here, so I got 0.25. Okay, if you use 2 minus 1.725, 2 minus 1.75, also you get the same value, and this is still not 0.015 as stated in the question, so you have to continue your iteration. So in order to continue to iteration number 1, you have to check the sign of the FAFC or FBFC, where it has to satisfy the intermediate value theorem condition. Alright, so now you can check FA and FC first. It's not have the same, the different sign, the sign is same. So you have to check FB and FC now. FB and FC. FB is positive, FC is negative. So yes, so now in the iteration 1, what happened is A will be take the value of C, the previous C, and B is remain the same. Okay, because we compare and FB and FC, it satisfies the intermediate value theorem. Okay, continue to find C. Find FA and FB, FC as usual, and then find epsilon. I got 0.125, so it's still not satisfied the stated epsilon given in the question, so I have to continue. Now I continue to check the sign again. So FC, FA and FC, yes, it has different sign. So in iteration number 2, the A is remain, and then B is taking the value of C. Okay, then continue, find C, FA, FB, FC, and then check the value of epsilon. It is 0.062, still not satisfied the condition. So continue to find the iteration number 3, okay, based on the intermediate value theorem, where FC, where FA, this one, FB and FC, it satisfied the condition. Okay, so what happened? A will take value of C and B is remain the same. Okay, so let's continue to find the value of the value of epsilon, and then still not equal 0.015, so I have to continue iteration number 4. Now you can see in iteration number 4, the value of epsilon is now 0.015, which is same as the epsilon given in the question. So now you can stop your iteration. Stop your iteration now when you reach at the stopping value. So your solution, we consider that this is the answer that you want. Okay, this is the answer that you want. All right. So remember, bisection method, you have to have two initial value, which is based on in the interval AB given in the question. And then bisection, and how to stop the bisection. There are two ways, which is it based on the FC, where it has to be equal to 0 or maybe close to 0, or push to 0, or when you reach at the stopping criteria, stopping value, which is stopping epsilon value. When you reach this stopping value, stopping epsilon value, stopping criteria, you can stop your iteration, and the solution is based on the final value of C. So that's all for bisection. Continue in the next topic, in the next video for the next method. Thank you.